In this video we're going to showcase the Metamorphic 20. These are the most commonly found minerals in metamorphic rocks, and some of these appear from the igneous 9 because they sort of survive the metamorphic processes, and usually they're found in rocks where an igneous rock transformed to a metamorphic rock via pressure, for example from granite to gneiss. Things like quartz, the hornblendes and the sodium feldspars can survive. But let's go ahead and showcase some of these, and we're going to begin with quartz. And quartz, we remember, can be any color, and in metamorphic rocks quartz is found a lot in gneiss, even in some schists, and of course in the rock quartzite. So remember, any of those rocks can be any color because quartz can be any color. The way to test for it, it scratches glass. It's a hard mineral. Calcite is technically a sedimentary mineral. However, when it comes to metamorphic rocks, calcite is found in the rock marble, which transforms from the rock limestone, and therefore we kind of categorize and put calcite as part of the Metamorphic 20 because it's found in marble. Muscovite, our old pal, familiar igneous 9 mineral. In metamorphic rocks, muscovite is very special because it occurs in a lot of the schist type rocks. Those rocks contain a lot of micas, and a lot of times what you'll find in those rocks is the very fine form of muscovite. So imagine it's basically sand-sized muscovite all clumping together due to pressure, creating all that schist that forms from in the metamorphic rock sequence there. Similarly, biotite is also present in metamorphic rocks in a lot of the schists as well. So remember, biotite is just like muscovite except it's darker. So always look for that black, brownish haze, flaky, and so on. Hornblende occurs in metamorphic rocks in multiple types of rocks, either foliated or non-foliated. Remember, hornblende has those needle-like crystals. That's the feature that kind of gives it away, along with its black color. So you should be familiar with hornblende crystals and what they look like in metamorphic rocks. They should be obvious. If the metamorphic rock is foliated, we would call that hornblende schist. If it's not foliated but has a lot of hornblende, we call that amphibolite. So if you go back to the metamorphic rock identification video, you should be able to see those two rocks. Okay. Potassium feldspar. Again, so far this is nothing new. You've seen these minerals before. There's our potassium feldspar, salmon pink, found in a lot of gneiss rocks. Gneiss meaning the metamorphic rock gneiss. They're also nice rocks, by the way. And it's pretty obvious if it's there. So there's potassium feldspar. Similarly, sodium feldspar can also be found in a lot of these nice metamorphic rocks. So looks just like potassium feldspar except it's white to off-white. Okay. All right. A mineral that is commonly formed in metamorphic processes is specular hematite. Specular hematite. It's the metallic hematite that you've seen in the minerals lab, or I've showed it to you a couple times with the streak. It's got a unique streak. So when you take a streak plate, specular hematite will leave a red streak. So shiny, metallic. It will occur oftentimes in schist type metamorphic rocks. Actinolite is a metamorphic mineral, and actinolite is green and has these needle-like crystals that sort of fan out. So if you look here, this is not hornblende. This is green, this is dark green, and this is actinolite. Okay. All right. Pyrite. I think you're familiar with pyrite, fool's gold. It could be found in metamorphic rocks as porphyroblasts oftentimes. Next up, we have chlorite. And chlorite is a common metamorphic mineral in the sense that a lot of the mafic igneous minerals will turn into chlorite as part of their metamorphic process here with the addition of heat. So chlorite is dark green. It is soft somewhat. You can scratch it with a copper penny. And this dark green is found a lot in rocks like greenstone, which come from the metamorphosing of basalt, and also rocks like phyllite. So that's chlorite. Serpentine is similar to chlorite in the sense that it is also a soft mineral, and the difference is serpentine is sort of this pale green, feels a little bit soapy. The problem is you won't be able to feel these because you won't be in class, but we can scratch it with a penny. Turns into that white powdery streak. So there's serpentine. Talc is another soft mineral that is found in metamorphic rocks, usually in schist form. In this case, I have white talc, but it could be other colors as well. This is more of the fine and powdery talc. You can scratch it easily with your fingernail, leaves a white powder. This is more of the crystalline version of talc, but also soft. And yes, that's what they make talcum powder out of, baby powder. Garnet, you've seen garnets before. It's the deep red maroon mineral with the diamond phase crystal structures. So there's our garnet. And in metamorphic rocks, these usually form in garnetites, so non-foliated, but they could also be found in certain schists as porphyroblasts, and they can be any size. They can be really small, they can be large. So here I have a combination. Remember, it's that deep maroon red color. It's got those diamond-shaped crystal faces. Here's a good one. Okay. But that deep red and the shape of the mineral gives it away. Okay, so that's our garnet. All right. Next up, we have Staurolite, another small mineral, but they could also be in any size. So Staurolite. And Staurolite's feature, remember, it's the penetrating crystals. That's sort of what gives it away. So I have some good sizes here and then some smaller ones. So with Staurolite, we're looking for those penetrating crystals. There we go. Okay. So when it's found in metamorphic rocks, you'll often see these again as porphyroblasts. Sometimes they don't have penetrating crystals. They look like this. But you'll see them in a lot of schists with some, or in the form of porphyroblasts. Next we have Andalusite. And Andalusite is grayish in color. In crystal form, it's sort of got these blocky, square-like cross-sections, but a lot of times it resembles hematite, except it's darker. So when you look at it in metamorphic rocks in fine form, it's usually got that grayish, tannish sort of color to it in metamorphic rocks, found in a lot of schists. All right, and kyanite. You should know kyanite, the bladed blue mineral. So there's kyanite, and it could be in any size, found in metamorphic rocks, usually in schist again, but remember, it's the bladed blue mineral there. So that's kyanite. Sillimanite. A couple of rocks might have sillimanite in them, usually again in schist form. Sillimanite is sort of this fibrous mineral. It occurs in these fibers, which is pretty cool. But when you apply pressure to it, it pretty much becomes into a metamorphic form. There we go. So that's sillimanite. It's pretty soft. Tremolite is another one. And this one also has needles, except it's not dark green like actinolite is. It could be in purple color as well, but usually it's white to off-white. But you look at these needle, really, really prickly needle-like crystals. Okay, that's tremolite. And finally, glaucophane. Glaucophane. Glazed, bluish in color, found in a lot of blue schist, as they call them. A lot of times resembles places where subduction zones used to be. The rocks have undergone a lot of pressure and glaucophane sort of forms. So there you have it. These are the Metamorphic 20. Unlike the Igneous 9, I don't expect you to know them. I just expect you to be able to figure them out given this video or some other means of help. But yeah, these are minerals found in metamorphic rocks. Hopefully this helps.